Alright, so we're going to continue on with Chapter 1, Section 7, Represent Functions as Rules in Tables. So we'll look at a couple different examples here. Alright, in this problem here, it tells us the domain of the function y equals 2x is 0, 2, 5, 7, and 8. It also asks us to make a table for the function, then identify the range of the function. Alright, so this table's already started. We've got a column for our x, our inputs. That would be all these together would be our domain. Here is the actual function and the outputs, what the y would be equivalent to. So start off by putting in the domain, the inputs. So we've got 0 is the first one. Then we've got 2, 5, 7, and 8. So there's our values of x. We're going to look at our equation here and plug in those values of x. So when x is 0, we'll plug that in here. We want to find the value of y. So we've got 2 times 0. 2 times 0 is 0, so our output is 0. 2 times x, here x is 2, so we are going to plug that in for x. We've got 2 times 2, which is 4. Then we're going to do 2 times x again, but in this case, our input, our x value is 5, so we have 2 times 5, which gives us 10 for an output. If we put 7 in for x, or the input, we have 2 times 7, that gives us 14. And putting 8 in for x, or the input, gives us 2 times 8, which is 16. So we've completed the table for the function. Now I want to identify the range. Well, the range is just all of the outputs or the y values. So we're going to express that as a set of numbers, and all these right here are our outputs or our y values, and that's going to be our range. So we've got 0, 4, 10, 14, and 16. Okay, so that's our range. So we've taken care of everything in that problem. Let's look at a similar one, just a different function. All right, the domain of the function in this case is y equals x plus 4. I'm sorry, the function x equals 4, the domain is 0, 2, 3, 6, and 7. Again, we're asked to make a table for the function, identify the range. So here is the function, x plus 4. Those are all our inputs, our domains. So I'm going to go ahead and put those in for our inputs, our x values. We've got 0, 2, 3, 6, and 7. Here's the function. So I want to plug the input or the x in for x here. So when in this case it's 0, so 0 plus 4, well, that gives us 4 for an output. If I plug the x value, the input in to the equation, we've got 2 plus 4, which gives us 6. So if we take x plus 4 and we plug 3 in for x, we've got 3 plus 4, which is 7. Again, do the same thing, but now use 6 for x. 6 plus 4, that gives us 10. And the last one here, 7 plus 4 gives us 11. So we've completed the table. Now we need to identify the range again, and the range is just going to be all the outputs or the y values. So I'm going to express those as a set of numbers. So it's all of these in this column here. So our range is going to be 4, 6, 7, 10, and 11. Okay. All right. Now we're given this table, we have the input and the output. We want to write a rule for the function. Well, or write an equation. We could say that too. So we write a rule. I'm going to let y be the output, and we're going to see what happens here. So look at the input. Here it's 0, and it goes to 2. So that's an increase of 2. Here it's 1, and it goes to 3. Again, that's an increase of 2. Here the input is 4. It increases by 2 to 6. Here the input 6, it increases by 2, becomes 8. Here the input is 10, and it increases by 2 and becomes 12. So the input values, remember, that could also be the x's, and the outputs can be the y. So look at what happens to each input. Every time you start with an input, 2 is always added. Well, the input is represented by x. Okay, so this represents the input right here. Every time there's being 2 added to the input. So our function, our rule for the function is going to be y equals x plus 2. The input is always have 2 added to it. Okay. Here's a similar one, just with it's going to have a different rule. So again, I'm going to start with this. I'm going to look at what happens to each of the inputs. Well, we start at 1 and it goes to 0, so that's a decrease of 1. We start at 2 and it goes to 1, so that's a decrease of 1. Start at 4 and it goes to 3, that's a decrease of 1. And we start at 7 and it goes to 6, so that's a decrease of 1. So each time it's decreasing by 1. And again, remember that the input we can think of as being the x and the output in this case being the y. So every time, whatever the input in is, it's being decreased by 1. So that represents our input. No matter what it is, it's decreasing by 1. So our rule for the function is going to be y equals x plus 1. And that's it for the problems I'm going to show you. Now it's your turn. So you get to try these two problems here, bring them in, and we'll take a look at them tomorrow.